In this important section, we define normal random processes and point and renewal processes. So again, we repeat and we add new definitions in order to facilitate your communication and work. So a normal random process is defined as a process which, when it goes through the linear system, it remains normal. So this is a self-definition. So the definition, it defines itself. So if for any number of samples, like if you have time, and then you choose an arbitrary integer numbers and then take t1, t2, etc., and then tn, if you take these samples and then if these samples are jointly normal, you could say, oh, my random process is normal. So this is one definition. In that case, because they are jointly normal, a jointly normal random vector is characterized by the mean and covariance. So for these random variables, the means are given by the mean of the random process, and then the cross covariances or the covariances of these random elements or random samples are calculated by that, because you can just replace these t by t1 or t2, t3, etc., and then these t1 by t1, t2, or by t1, t3, etc. If you have these two functions, you have the joint distribution of the n random variables. So the mean, this random variable has the distribution of one of the samples can be written like that, but if you take n samples, you can write it in terms of the characteristic function, so which is equal to, for a normal distribution, is exponential of j times omega I times means, and the double sum, 1/2 of double sum omega I or omega k times covariance. So this is the distribution in characteristic domain. In PDF domain, you can take the Fourier inverse of that. That's going to be a bit more complicated, so it's much easier to manipulate in characteristic domain. Existence theorem says that given any function mu t and any positive definite function, this is a valid joint distribution. Therefore, based on the existence theorem, there exists a normal random process with this mean equation. So in summary, if you talk about mean and correlation function which is positive definite, then we are okay. We don't need to make sure that something exists.